So what I want to talk to you about is, as Kareem said, it's something that we've been working on. But let's kind of kick this off. Now, you're here at the conference having a wonderful time, I hope. But someday you've got to go back to work. Now, Friday. Let's just fast forward. It's Friday afternoon. And you're like, OK, I'm ready to call this a day. I'm going to go home. I'm going to have a great weekend. And then Slack pings. And it's the boss. And the boss says, hey, would you mind? You've been out of the office for the last couple of days. Could you just do a deployment for me? So you think, well, I don't really want to deploy on a Friday. I don't want to screw up my weekend. I don't want to risk anything. But you really like your boss. So you're like, no worries. I'm going to do this for you. So you do your deployment. You push your code. It runs through the pipeline. It ends up in prod. And, that's great. And everything's fine. And then like, oh, I've got no audio. So let me interpolate what's going on here. So your colleague phones you up, and he's like, hey, Nick, are you doing a deployment into production?
I'm just about to go live again, but I just got a call from Paige Judy.
Oh, Paige R. Judy?
Yeah, that's her. Yeah.
Oh.
She keeps calling me with her problems.
OK. Oh, they may be my problems.
I'll get rid of this clown, and I'll be right there.
Predictably, well, it went wrong. So I'm Nic Jackson. I've been deploying badly into production for nearly 25 years now. I want to teach you the error of my ways and show you a solution that means you don't have to worry. So let's kind of look at this in a little bit historically. Now, I think where we stand right now in terms of software and application development is pretty good. We've come a really long way from when I first started writing software and working professionally. But I think the key thing is that we've seen over those years, you can always go further, always go further. And when it comes to deployment, the two kind of things that I've always faced in my career have been this. One is that I write code, I run my tests, I have manual tests and acceptance tests. I'm just never really sure it's going to work in production. And the other thing that I've always struggled with as a developer is, well, I really want a single pane of glass. I kind of want to be able to see the full information about my application in a kind of a single succinct place. Now, we've got the tools to be able to do this. And in fact, HashiCorp's been kind of building those for nearly a decade now. But I think the key thing is, it's like how you craft them together to create a great developer experience. Because that's what I want to talk to you about. I want to talk about developer experience and how, if you're a developer, what this means to you. But if you're working in sort of operations or platform engineering, how you can provide a great developer experience for your teams. A little bit of a caveat. What I am not going to show you is a product announcement. What I am showing you is how I have leveraged our tools and built some automation around them to be able to do progressive delivery. And we'll kind of run through this step by step. So first things first, let's look at that developer problem. Now, we've been writing tests for a long, long time. And we write a lot of them, but it doesn't necessarily equate to successful deployment. And the reasons behind this are, well, there's quite a few. One is that the production systems can be different from the systems that we're running our tests on, that we can kind of have things in difference of scale, number of nodes, even different operating systems or even kind of schedulers. And the other thing is kind of, I think, more important, you start to deal with traffic. You've got different conditions in your production environment than you do in your dev and your test. And it's really, really difficult to kind of simulate those things. And if you can achieve it, it's actually really expensive to do so. So maybe there's a better way. And before we get to that better way, let's look at the error of my ways. This is literally a history of how I've been bodging deployments over the last 25 years. Now, it all started off around about sort of 2000 to 2005, when I started working with the internet. And this was my approach to writing and deploying to production. I'd code. I'd build my code on my machine using some weird incantation, which is only ever going to work on my machine under certain hours of the day at certain days of the week. And then I would literally just throw that code with FTP into the production server where PHP would crash. I'll scrabble around trying to revert the code. I won't have the backup files, and I'll spend the rest of the day apologizing to my boss and the customer. I'll be honest with you, it really wasn't ideal. And I kind of recognized this, but I was treating the customer like my automation. They were my automation and monitoring. Okay, well, it worked. But I got sick. I got sick of kind of lying to people and saying, oh, it looks fine to me. Are you sure you can't just refresh your browser? Oh, it's working for you now. Great. I started to look to see if there was a better way. And in about 2005, I came across this book, which was Test-Driven Development by Kent Beck. Now, why I kind of bring this up is it started to get me to think about consistency and reproducibility. I started to kind of think, well, there's got to be a better way than just YOLOing code into production and hoping it works, which it invariably didn't. And I started following continuous integration. I'm using Jenkins server and things like that. So now I'm writing my code. I've got my build, which is reproducible. I'm running my automated tests. This is great. I then SSH my code, because I'm now dealing with binary artifacts rather than PHP scripts. It doesn't work. I then scrabble around trying to revert it and spend the afternoon apologizing to the customer. OK, so where do we go next? Well, it's an evolution. So we go to continuous delivery. Now, one of the things that I'm dealing with is the speed of which I can revert my code, and also the complexity around the deployment. I can bodge the deployment. So I start to look at a continuous delivery process. I've still got my automation around building my code, but now I have automation around deploying the code. This is great because, invariably, it doesn't work. I have to revert it, and then I spend the afternoon apologizing to my boss and my customer. But the thing is, around that apology, now I've got a little bit more automation. It's just a bit quicker. So where do we go? Well, where we go to is here. And that's progressive delivery. It's somewhere where I wish I was 20-odd years ago. But ultimately, the technology didn't exist. To be able to do effective progressive delivery through the steps that I'm going to show you, you've got to use software which allows you a high level of automation and control over the routing of the traffic of your application. And we'll see how this works. But the process is this. I write code. I build my code. I deploy it automatically. And then something else, which isn't my customer, is monitoring the health of my application. If the health of the application is good, what it automatically does is it slowly increases the percentage of production traffic that goes through to it, rather than just throwing everything at it. Now, the benefits of doing it this way means that, well, when it does go wrong, I don't necessarily have to wait to roll it back and go through the whole automation deployment process. I'm just flipping a switch, and I'm adjusting the traffic routing, and automatically, I'm back on my last known good state. And we'll see this in action. OK, let's go. Now, if you were going to do this manually, like I'm about to, these are all of the things that you've got to do. And I don't know if I want to do that, but we'll do it for the process of seeing how it works. But you need to be able to consistently build your code, deploy it, and you've got to have a modern scheduler which can take action around that deployment. You need something which can automatically handle the removal and the promotion. We also need a system where we can measure the efficacy of the application correctly. We need to be able to look at the application's metrics to determine its health. Not using health check, we need to do a passive check by looking at the actual requests. And we also need something which is going to be able to allow us to shape the traffic, to be able to dynamically load balance our requests between our primary and our canary. And in those things, we can use Consul Service Mesh. So let's look at what it involves. So manual release process. Now, our application setup is dramatically simplified for this terrible diagram, but there aren't that many components. We have Nomad. We're going to be using Consul. We have a two-tier application, API, which talks to payments over the service mesh. And eventually, I'm going to show you some automation, which kind of ties all this together with the release controller. In terms of the configuration we need to create inside a Consul, well, it's this. We're going to create a service router, a service splitter. We're going to kind of see how we can use a service resolver and how we can use all of those components to dynamically shape our traffic, and ultimately how the automation can do it for us. So first things first. Now, in order to be able to do an effective canary release, we need to be able to effectively measure the health of the application. Again, not an active health check, but we need to look at the traffic which is flowing through the application, and we need to determine what is a success and what is a fail. Now, layer 7 protocols with gRPC or HTTP, we can use HTTP status codes, or we can use gRPC error codes. But in all of those instances, we need to report that information consistently in order to kind of do some interrogation on it. And to do that, we can use Consul Service Mesh, and Consul Service Mesh can configure each of the sidecar proxies to be able to kind of be scraped to pull metrics in a consistent way. So to configure that up using Prometheus, we can create a proxy defaults, and then every sidecar that's launched in the system will have Prometheus metrics enabled. So that's kind of like step 1. Step 2 is we need to think about service defaults. Now, why do we care about service defaults? Well, we care about service defaults because in order to understand what is an error and what is a success, we have to be looking at the layer 7, the application layer protocols. And we need to be reporting those effectively and correctly. So I need to be able to kind of tell Envoy, hey, this is an HTTP service, so measure my sort of metrics around HTTP protocol. I could also configure gRPC, TCP, et cetera, et cetera. We're going to do this on an individual service level in this config because, well, my application doesn't consist of just HTTP services. I've got a mixture of gRPC and HTTP and TCP. So I'm going to configure that service by service. You could also just put that into your proxy defaults. And then we kind of have to think about, well, how do we get the data from the sidecar proxy and into Prometheus? Now, Prometheus has had sort of a Consul kind of scrape config built into it for a number of years. And we can literally just leverage that. Now, the example I'm going to show you is Nomad-based. It works exactly the same no matter what scheduler you're using. I'm going to configure my scrape config, and I'm just pointing it at my Consul agent. Because Prometheus can then use the service catalog. It can determine all of the instances that exist that I want to measure. It can determine what the IP addresses and the ports of the metrics are, and then it can start scraping. Now, to add a little bit of sort of richness to that information, what I'm going to do is I'm going to augment every metric inside of my sort of Prometheus scrape with the name of the job from Nomad and also the data center. Now, I could add a bunch of extra custom labels here, but these two are really, really useful for me. So then how do we kind of go about making sure that our application is configured? So again, using a Nomad-based example, what we need to do is we need to configure a port for the metrics. So I'm going to configure a Nomad port. It's a dynamic port there, and it's going to point to 9102, which was the same port that I'd configured in my bind address in my global proxy config. And then I need to configure a service. So you're thinking, well, why do you need a specific service for the sort of just the metrics? And the reason is that at present, when you do your service registration with Consul, you can only register a single port. And that single port is generally the main application port. So because we want now also add this metrics port to the service catalog for Prometheus, we've got to create a separate service. And you know, this is subject to change, but right now, this is kind of how we're going to go about doing that. So we define the name. We're just going to call it payment metrics. We're going to tag it so that we can filter in our Prometheus query, and we're adding that job and the data center from the Nomad interpolation there. Lastly, every service is running on the service mesh. Now, this is kind of a prerequisite for being able to do this kind of stuff. In order for Consul to be able to smart route and smart load balance your traffic, it really needs to be leveraging that service mesh. So we're going to launch that sidecar proxy. Nomad's going to inject and set everything up there for you. So what that does, well, that's going to create the service catalog. Your services are going to be running. They're going to be running on the service mesh. And now we want to start thinking about how we can start controlling the flow of that traffic. So how do we do that? Well, the first thing we need to do is we need to kind of think about our known good state, which is our primary, and our new deployment, which is our candidate. Now, when you register everything inside a Consul, it's all just going in as payments. You have the individual service instances, but the high-level service is just payments. So in order to kind of differentiate and to pick and choose the correct service instance, what we can do is create a service resolver inside of Consul's service mesh config entry, and we can define subsets. So the subset here I'm creating is for the candidate, and I'm giving it a filter. So the filter is just the standard filter parameters inside of the health check API, but I'm going to say that for a candidate, it must be not have the tag primary. And then I'm going to create a second subset, which is primary, and now I'm saying it must have the tag primary. So then I'm going to create a default subset, because by default, given the absence of a service router or any service splitter configuration, I want all of my traffic to go through to my primary. So that's kind of like my initial condition. Then we look at how we kind of going to do that smart routing. So what we said was we want to gradually introduce the traffic, gradually roll things into production. And to do that, we can use a service splitter. So we can basically do weighted load balancing across every service instance. Now, because this is all on the service mesh, this is happening at the sidecar proxy level. There's no central dependency. So we define this service splitter. And again, I'm using those subsets that I created previously, and I'm just going to set a weight. So I can say for my primary, let's have 90% of the traffic. For my candidate, 10%. You know, worst case scenario, if you're running something like this, if the candidate is a complete dud, 90% of your traffic is still going to succeed. And that's kind of the beauty of what we're going to see. Hopefully, without me having to revert to the pre-recorded demo, which looks like this, by the way. I'm not going to cheat just yet. OK, so I've got my application running. And you can see it just there. Hang on, GB, zoom. So my application, this is just kind of making a bunch of calls to the app. What you can see is the upstream. Now, it's using the upstream of payments from API over the service mesh. And the name of the payments is the current version, which is payments v1. So we're going to kind of see that change over time. So the first thing that we want to be able to do is to start applying those defaults. So we've got the defaults, and the first one we want to do is apply the service defaults for the payments. Now, I've already pre-configured the proxy defaults, so I'm not going to kind of do that step, but I'm kind of setting my service defaults here. So let's just apply that. So Consul, config, write, and the name of the file, which is service defaults. So that's been written. So if I kind of look at that, Consul, config, read, kind, no, not service. Come on, Nick, get with it. Service defaults, name, payments. OK, so that's in the system. So we've now set, and we've told Consul that the payment service is HTTP. So the next thing we want to do is we want to apply that service resolver. So we're going to create the service resolver with those two subsets. We're going to have our primary, and we're going to have our secondary, or candidate. And it looks like that. So Consul, config, write, service resolver. And that will be on the system now. So what's the next thing we need to do? Well, the next thing we need to do is we need to create a clone of our existing known good deployment. Because we need two versions of our deployment. One which is owned by the system, that is our last known good version, which is our primary, and the one which you're going to be submitting, or the CI system is going to be submitting. And that's just the existing name of the job. So I'm creating my primary here. It's literally just a copy of the existing service that's running in Nomad there. The only difference is if I look here at the service, I'm tagging this as primary. So because I'm tagging this as primary, what it will mean is that my service resolver, that filter condition is going to work. So when I look at the service instances, I'm going to be selecting those. So we'll kind of see how that works, right? So let's do that. Nomad run primary. So that's just hitting the system. While that's kind of hitting the system, let's look at our Grafana dashboard. Quite happily ticking away there. We don't have a sort of a configured release, so we're seeing all the traffic just there. And we'll see this change in just a second. Now, if we look at our payments service, what you can see are those service instances. Now, I've got 6 service instances here, but the traffic is only flowing through to 3 of them, because I haven't sort of configured that yet. And you can see that here. Let's do that in just a second. There we go. So everything's still on payments v1. Now, what we need to now do is now we've got our primary and it's all good. Let's set 100% of our traffic to our primary, and then we've got a release which is in a state that we can start doing a progressive deploy. So Consul, let me just clear that actually, make it easier for you to read. Consul config write, I don't know, I can't remember, 5, 6, service splitter. Let's apply that service splitter. And while that's kind of applying, let's have a look at what that is. So I'm going to send, well, that's a mistake. I'm going to send 100% of my traffic and 0% of my traffic to the candidate. And I'm just going to apply that again. Right. Now, what you're going to kind of start seeing is that everything now has changed there. So you see that the name there, it's now saying payments primary. And all I've done is reconfigured the service networking inside of Consul Service Mesh to now select all of these service instances which are tagged as primary. If we look at our Grafana dashboard, and this kind of lags, maybe 40-odd seconds or so behind the real traffic because of the scraping and the aggregation, but you can see now that the line has turned from yellow to green. But the reason for that is that we're actually now sending all of our production traffic to the primary instance. Now, important thing to note, 0 errors. So I've completely reconfigured the service level networking of my application, and I haven't even caused a single interruption, which, I'll be honest with you, is not usual for me. But now let's kind of like start to look at how we're going to split that traffic. So let's kind of accelerate things. I'm happy that everything's working. I am going to start sending 50% of my traffic through to production. That's now written. If I have a look at those, console config read dash kind service. I am one of those annoying people that can't read without talking. Payments. And you can see we've now got 50-50 traffic. Quick look at our Grafana dashboard. And again, when this updates in about sort of 30 seconds, where it goes, you can now see that we're now sending an equal amount of traffic to our new deployment and our existing deployment. And I haven't touched a single thing. All I've done is changed configuration. It's happened all 100% automatically. Now, the disadvantage is that you've got nowhere to go to, right? Because I need to monitor this for a couple of hours whilst I kind of gradually increase that traffic. Right. in reality, this is not a workable process. You know, it works fine, but I don't want to have to do this manually. And why should I? Because actually, all of this configuration can be driven automatically. So let's take a look at that. And I'm really pleased that so far, I don't need the automated demo. Now, the automated release process. What we're going to do is we're going to repeat exactly those steps, but now we're going to use the little bit of code that I've written, which is going to do all of those manual things that I did automatically. In order to instruct it, I'm going to configure it with a few things. So I need to configure it with the name of the Consul service. Now, the Consul service could potentially have a different name, and does in this instance, from the actual Nomad job or the Kubernetes pod. So I'm going to specify what that is. I want to monitor the payment service. Now, the plugin I'm going to use is which scheduler? Well, I'm going to use Nomad, as I say. Like, you know, we can do this on any environment that you want, but I'm doing it on Nomad. What I want to be able to do is I need to tell the automation what job needs to trigger the rollout process. So I'm specifying that it is payments deployment, because that's going to be the name of my canaries. And I could use a regex here if you've got something more complicated, but we're keeping it simple. And then I'm going to specify the interval. So at what interval do I want to check the health of my application? So I'm going to say 30 seconds. So every 30 seconds, I'm going to check the health of the application, and I'm going to look at all of the errors that occurred in the previous 30 seconds, and that's what I'm going to use to determine the efficacy. The initial traffic, well, what is the initial traffic that I'm pushing at my production? My initial production traffic that I'm pushing at my canary. This is really dependent on risk, really. You know, you could start small, it takes longer for the deployment to complete, or you can go big and it's quicker. It is very much depends on your individual circumstances, but I'm choosing 10%. And then in the same sort of vein, how do I want to increase this? Well, I'm going to increase it in 20% blocks. Every 30 seconds, if the app is healthy, increase it by 20%. Max traffic, again, at what point do we want to determine that the application is healthy? Now, if you're relatively happy that if you, say, hit 50% of production traffic on your canary, just promote it. But if it's a real high-risk service, you might want to say, no, I want to absolutely wait until I have a very high percentage of my production traffic. Now, if you remember back to what I was kind of saying in the beginning, load is a major factor on the success or fail of a deployment. Just because an application version is fine at 10% traffic, it does not necessarily mean it's fine at 100% traffic. You could have a deadlock, you could have any manner of things which can cause a kind of an issue which is affected by load. In terms of like a rollback, because the key thing that we want to be able to do is we want to be able to roll back our application in the event of a failure. So we can configure that too. I'm speeding this up for the purpose of a demo, but in the instance of 2 consecutive failures, then I'm going to roll back, and I'm going back to my last good known state. And what is that measure? Well, you know, the beauty of using Consul Service Mesh is that Consul Service Mesh gives you a consistent way to report all of the application metrics within your system. So all of the varying kind of HTTP requests, the size of the bytes, the latency, everything is consistently configurable. When I used to work in my last company, we kind of had an agreement that we would name all of our metrics consistently. And the reality is it kind of never really worked out like that. The beauty of using kind of Consul to kind of report those metrics is it's absolutely consistent. And because it's consistent, it's automatable. So I'm looking at request success, and I'm looking at duration. Why am I looking at duration as well? Well, it's optional, but I may or I may not at some point have deployed an application into production, which was actually 100% healthy. And the reason that it was 100% healthy was because I'd actually managed to completely short-circuit the request router, and it wasn't actually doing anything. So by looking at things like request duration, you can kind of get another measure on what the health is of your application. And kind of if you want to go even further than that, you don't even need to look at the kind of the inbuilt metrics from that one system. It could be something external. It could be customer success, could be, I don't know, basket abandons, it could be amount of money you've taken through PayPal. Varying different companies have a measure of success on what good is like for their applications, and you can configure all of those. Just kind of a quick kind of heads up on those metrics. We're just writing some Prometheus queries. I don't have to write these. The system is doing it all for me, but that's what it looks like. I'm basically just counting the number of requests over a 30-second period, and I'm sort of dividing that by the number of good requests. So the number of failed requests over good requests is going to give me a percentage between 0 and 100, a success rate. The duration, again, I'm just going to look at the 99th percentile. So let's see it. So first things first. Let me clean up my application, and let me just make sure that that's rolling back. All right. I just did that with brute force, which is why you're seeing the errors there. OK. So the first things first. Let's go through and let's do the configuration. I'm not going to have to do 100,000 steps. What I'm actually going to do is something sort of pretty straightforward. So I've got my payments deployment running. 3 instances. Let's configure the release. All right. So actually, first things first as well, let's look at the status of the release controller. So I'm just going to look at this status. We don't have any configured releases. So let's do that now. I'm just curl. And I'm just doing this manually instead of using Terraform. And we're just going to do the name of the file. Wow, if I could type. And it is Nomad, valid Nomad release. It's this one here. Valid Nomad release.json. No, .json. Well, you know, if I can actually remember the URL correctly. V1 releases. And then if I actually bother to type this correctly. All right, so that's configured. So what the system is doing now, we just configured a release. So the release controller is going about and creating all of that console configuration that I just manually went through. What you're going to see is that it's automatically cloned my payments deployment, and it's created payments primary. So it's taken ownership of my existing deployment. Now, it's going to kind of run through a couple of checks. It's going to make sure that the application is healthy. And then once it's healthy, it's going to remove the old payments deployment. So we're in a known good state where we can kind of start going about our release. And that's just happening now. So it's just cleaned up all of the old stuff. We're going to kind of see our metrics here in a moment. And everything's going to be pointing at the primary. So let's have a quick look at our config. So Consul, I'm pretty sure I can get this from reverse shell. Service splitter. So the release controller has automatically created me my service splitter. It's pointing at the primary. We're ready to do a release. So we're just going to wait 2 seconds for this. There we go. We are pretty much ready. So now let's create a new release. So how do I now create a release? Well, what I'm going to do is I'm going to do Nomad run, could be kubectl apply, and but I would use Nomad if I was you. And we're going to do payments, boop, v2. So now we've got our v2 version of our application launched into production. No traffic is going through to it because the service splitter is still pointed at the primary. Once that kind of goes healthy, what you're going to do is you can see by looking at the kind of the status on the top left that the release controller has detected that there's a new deployment, and it's kind of just going through its process. So now it's going to wait for its initial 30 seconds, which we had in the configuration. It's then going to start changing the service splitter config. So there we go. It's done that immediately. So we've automatically now started to send 10% of traffic through to the service. And we're going to kind of start seeing that show up in our application dashboard in just a moment. But kind of like while we do, you know, like one of the things I think is quite interesting is like, why am I doing this manually? Why am I kind of looking through this stuff when I could be kind of like looking at things in a much more interesting way? So let's see if we can get the Minecraft stuff running while we wait. And maybe not. But running through there, now 70% of our traffic. So if we look at the logs, and if we look at the Nomad logs, and let's just have a look at the logs on the release controller to kind of see what it is doing when it was basically pretending to be Nic earlier on. So I'm just going to look at the allocation logs there for the release controller, and pause that. So what you can see is that the release controller is automatically executing those queries that I had configured against Prometheus, and it's looking at the result there. So here it's determined that it's got a 100% success rate, which is great, because when it receives a 100% success rate, it's going to start increasing the traffic and rolling that traffic up and out into production. And there it goes. It's starting to slowly increase that traffic. We're going to eventually see it 70%. Next check, it's going to hit 90. Then it's going to go up to 100, and it will promote that deployment. And I just don't know why Minecraft doesn't want to run on this computer, but it is what it is. 90%, again, sort of the interesting thing, and we're looking at the error logs there. We've dynamically shaped and manipulated all of this traffic, and we haven't had to kind of, we haven't suffered a single thing. There's no outages. It's automation which is doing everything for us. We're nearly there. We're going to hit, OK. So we're complete. The release controller has determined that that deployment is successful. It hasn't detected any errors. What it's now doing is it's copying the candidate. It is promoting it to the primary, which is our now new known good state. And it's going to remove the candidate. And it's going to do that all automatically for us. We're going to see that in just a second if we look at our Nomad jobs. And eventually, that is going to come through, and that deployment is going to be removed. There we go. It's gone. So it's completely removed it. Now, the release controller owns that deployment pipeline. That's pretty good in my book. I mean, you don't like it? All right. I've got a thick skin. But we've just used automation. We've just kind of created what actually is a really good developer experience by assembling a bunch of our tools and kind of just wrapping some automation and process around it, which, of course, you can kind of feel free to kind of use and share. Let's quickly back at the slides, because let's look at the error situation. Because in the instance of a failing release, what we want to be able to see is it roll back. So let's force a failed release. So what I have here is an error version, my usual version of the code. Now, all I'm doing to kind of simulate that is I'm using an application called fake service, and fake service allows me to manually trigger the number of errors which are reported by the system. So 30% of all errors that the service receives, it's going to result in an error. The release controller should therefore roll this back. So let's see that run. So again, we've got that rolled out. The release controller has detected that there's a new version of the deployment. It's in its monitor phase. And what it's going to be doing is it's just waiting for that sort of check procedure. It's waiting for all of the service instances to go healthy in terms of their health checks, not their actual service health, which we're only determining from the traffic. And it's then going to start sending 10% of traffic through to the system. And we're going to kind of see that happen. There we go. It's happened right now, right? So 10% of traffic. Now, when we kind of look at that, we're also going to start seeing errors come in on our dashboard, because the system is actually going to be reporting errors. Again, there's a little lag on this, but the release controller is aware of those errors. What we're not going to see this time is we're not going to see the release controller continually increase the traffic to the bad version of the service. It's going to kind of run a couple of checks, and it's just going to say, well, look, this version of the service is no good, so it'll automatically revert the traffic back to the primary instance and remove the new version for you. And that'll take just about sort of 30 to 60 seconds there. We can see the current status as failing. It's currently failed, and it's now rolling the traffic back. So it's going to automatically get rid of the canary because it's a bad deployment. It reverts the traffic to the last known state. I'm at home on a Friday afternoon. I'm aware that the situation has gone on because I've got the alerts through Slack or whatever sort of mechanism you want to use, but I don't have to do anything until Monday. And that is, in my book, a result. Very, very quickly, one last little thing. How do we kind of hide or cover up those errors from the end user? Well, we're going to do that by looking at a retry, because we can actually retry a failed service call. Now, you've got to be careful with a retry, because you've got to think about idempotency. It's no good retrying something like a post request which is taking a payment unless you're making sure that you don't accept duplicates. I mean, your financial controller might thank you for that. Your customers won't. But again, using Consul Service Mesh, we can make those configurations dynamically on the network, and we can specifically specify what constitutes a retry. So I'm only going to retry HTTP gets, and I'm going to do it 3 times. So let's do that. So Consul, let me clear this. Config write payments retry. And now what I'm going to do is I'm pushing that payments error out again. So we've seen here it's automatically rolled it back. We're pushing a new deployment. What we're going to see this time is we're still going to have errors because we've got a bad deployment. But instead of the error count there increasing, what you're going to see is the number of retries increasing. Because we're actually going to be hitting the bad service. We say, hey, that's a bad request. So we're going to divert the request to the good version. That's going to mask the problem from the end user. It doesn't get rid of the problem, but it ultimately kind of hides the problem from the end user, which gives you the time to fix the problem and to be able to roll out that service again. Let me see in the last 30 seconds that I have whether this thing's going to kind of start ticking in. And we've got 10% traffic running through there. Oh, the clock is really ticking down. There we go. So look, error count's going down, retries are going up. That means the retry has now protected our bad version of the service. What's going to happen? Well, the automated release process is going to take over. It's going to detect that there's an issue. It's going to remove it, and it's going to roll it back, just like we saw previously. Now, the customer is completely unaware. I don't have to lie to anybody, and ultimately I can enjoy my weekend. Now, I hope this has been interesting. I hope it gives you some inspiration of some things that you can build for your application developers and build for your platform teams. Come and see us in the Dev Lounge if you kind of want a more sort of one-on-one walkthrough. I can also show you some configurations for other platforms. And we're going to be kind of releasing this open source just so you can kind of use it as exemplar. And we'll be pushing that out when I kind of get around to writing some documentation around the Nomad release. But, hey, we've been trying to do some conference talks. But thank you so much. I'm Nic Jackson. If you have any sort of questions, please ping me. And I hope you have a wonderful conference. Thank you.